Hi everybody and welcome to Column Cymru revision sessions. The session this evening will focus on GCSE mathematics and will be presented by Mr John Casey from Pentre Harvard School in Swansea. The session will last around 45 minutes where Mr Casey will run through the relevant content. If you have any questions during the session, please use the question and answer section and we'll do our best to answer you. Before the end of the session, you will see that there's a hyperlink in the question and answer section. If you're happy to leave your name and email address, we would love to keep in touch with you so we can send you information about future events. You can click on the link at any time during the session. Today's session will be recorded and the recording and any relevant resources will be uploaded to the e-sgol website under the Column Cymru tab. Thank you, Mr Casey. Over to you.
Okay, thank you, Mr. Dixon. Welcome back. So if you joined us last week, we did the sine rule. So this is kind of a continuation of that. They're not exactly the same rule, but my advice would be to watch the sine rule recording before doing the cosine rule. You will find some exam questions do use both. So you need the sort of sine rule as the base knowledge before moving on to what we're doing today. But welcome if you joined us. So let's have a look at what we're going to be covering. So we're going to be finding the formula and the sort of explanatory notes on the formula page, understanding how to use the cosine function on the calculator, using the cosine rule to find the missing length in a triangle, using the cosine rule to find the missing angle in a triangle, and then we're going to cover some GCSE questions as we have done before. Okay, so let's have a look what the cosine rule is all about. Okay, so two main times that you're going to be using the cosine rule. So first of all, when you have two sides and you include an angle. So if you look at the first picture, I've just highlighted those two sides in yellow. We've given them a length of 8 and 10 centimeters, and of course I've marked the angle of 34 degrees. So if we be given those two lengths and the angle between them, we can use that information to find the angle, to find the side that's opposite that angle. The other time you're going to use it is when you're given all three sides. So looking at the second triangle, so if we're given all three of those sides, we can use that information to find any angle within that shape. Okay, so any angle can be found with that much information. Okay, so looking at the formula page. So if you tuned in last week to the video, we discussed the formula page. We're looking at the sine rule, but also on that formula page is the cosine rule. So please remember, GCSE, don't just sort of disregard this page. There's lots of useful information, lots of good stuff that's gonna help you in your exam. Now the cosine rule does look a bit scary when you first see it. There is a lot of information. It does look quite a complicated looking formula, but it's okay. When we start using it, hopefully you'll find it fairly straightforward. But the big confusion a lot of people have is what do the little a's mean, b's, c's? There's also a capital A there at the end. So what does that all mean? And then there's this little explanatory notes. So there's a triangle given to you where capital A, B, and C but the vertices of the triangle, so they're the angles, so they're going to be angles in the question, and the lowercase a, b, and c, they're going to be the sides in the question. Remember, with the cosine rule, we can use it to find missing sides, or in some cases, we can use it to find missing angles also. Okay, so let's have a look at sort of how it's used. So if we're finding side A, we're going to use it in the form that's given to us in the exam paper. Okay, so a squared equals everything else. I don't need to read it out. You can see it there on the screen. But if we're finding a different side of the triangle, we sort of need to adapt that and change the formula around. So to find side B, you can see that b squared becomes the subject of the formula. So b squared is over on the left-hand side on its own, and that's equal to the other two sides squared and added minus 2ac cos b. So 2 times a times c times the cos of angle B. Or of course, if we're finding side C, we're going to sort of adapt the formula again to use it like so. Now, I know that looks like a lot of information and a little bit daunting. You haven't got to remember all three versions of that. What you need to realize is whatever side you're finding is the other two sides you use on the other side of the formula. So if we have a look at the last formula, you can see there, if we are finding side C, it's the a and the b squared, and it's 2 times a times b, and it's always cos of the opposite angle. So cos of C in the case of when finding side C. Now that's the way it's given to you in the exam. When I teach this in school, I suggest to the pupils that they use brackets. So you can see the little red brackets that have just appeared. So I suggest to my classes that you put all of that bit in brackets, the 2BC cos A or whatever it may be. And I think that makes the workings a little bit simpler, and it avoids the confusion with the negative numbers. Okay, so I'm using a scientific calculator. I'm hoping at this stage you'll be pretty confident with this. So the cos button is there at the top of the calculator. So of course we're going to use that cos button as a function whenever we deal with these questions. Okay, so I think we'll go through an example. So let's take a look at this question. So this very much is it's a traditional question where the corners of the triangle are labelled A, B, and C. You're not always going to get that at GCSE, unfortunately. Sometimes it's going to be X, Y, and Z, and in some questions they're not going to be labelled at all. What is quite important to understand in this question is the little note in the bottom corner. Diagram not drawn to scale. So we can't really cheat and use our ruler to measure it, or use a protractor if we're finding an angle. They're not drawn to scale, so you have to rely on our sort of knowledge of the subject to work out the answer we need. So it says find the length of side C. So we just get my pen. I had a few issues with this last week if you tuned in, so I'm hoping it's going to be working today. Yeah, I think it's behaving at the moment. So side C is opposite angle C. So I'm going to put a little C there. And that's the side where we're trying to find. They could have said find side AB, the side from A to B. That's sometimes the notation that they use. So I'm going to use the formula I showed you earlier. So I'm going to start with C squared equals A squared plus B squared. And I'm going to subtract, remember what I mentioned earlier, I'm going to put all this in brackets, 2 AB cos of, it's going to be capital C this time because of course it's the angle that's opposite the side we're finding. Now that's probably the only time today that I'm going to write that formula out in full in that form. I think from now on I'll probably just use the numbers in the question, but we'll see that on the later examples. So let's have a look. Let's try and sort of put some logic. So I'm trying to find C, and the two sides are going to be 9 and 7. It doesn't really matter which one's 9 and which one's 7 for the purpose of this. So I'll do 9 squared, which we'll work out in a second, plus 7 squared, take away, and we're subtracting all of this. So I'm going to put 2 times A times B, which is 9 and 7 again, times 9 times 7, and that's all being multiplied by the cos of the angle. Now the angle is opposite the side that we're finding, like I mentioned, and that's going to be 44 degrees. Now I know that looks like a big chunk of workings, that looks like a lot of stuff, but if you're quite confident with your calculator, you can type 9 squared, or you can work out 9 times 9 in your head, plus 7 times 7. That's very straightforward to do. And we're going to take away all of that, but I would definitely use the brackets on my calculator, and that gives me an answer there of, let's have a quick look. So 39.363. Now, a really common mistake that I've seen in the past is people will leave that as their final answer. So let's look at the logic of this. That side of the triangle is 9, that side is 7. It's pretty impossible for that side C to be 39.363 because that's way, way too long. Okay, so we need to sort of adjust that. We need to do something, but I haven't found C yet. I found C squared. So what I'm actually going to do is square root that. So we're square rooting both sides. Remember, the square root of C squared is just C. And then the square root of 39.363 comes out as 6.3. That's rounded to 1 decimal place. Of course, centimeters to 1 dp. Now I look at that answer. Does that make sense? Yeah, that works fine for me because that is around the size number I was expecting with the two other sides that I was given. Okay, so let's take a look at a second example, and then I think after that there'll be a chance for you to try a few. Now, there's no A's and there's no B's and there's no C's in this question, so I kind of have to sort of think, what am I finding? I'm finding PQ. I could call it PQ in the workings, or I could just label X, or I think I'll label X for the purpose of this question. So I'm going to do X squared because that's the squared is of course part of the formula. It's the other two sides squared added together. Doesn't really matter what I put first. I think I'll put 18.7 first. So 18.7 squared. I'm adding on 32.6 squared, and I'm taking away 2 multiplied by, I think I'm going to struggle to fit this all in one line. I might have to go to the next line. 18.7 times 32.6. I have to do the times the cos of 122, because that is the angle opposite the side that I'm finding. If you can an exam, I think you could easily fit this on your page in the exam. Try and do it on one line. Unfortunately, I've had to go to a second line purely with the amount of space that I have on the screen. Right, so I type all out on my calculator. Again, I've used my brackets for the second part. I'd probably also use my squared function. So probably x squared, it will be on your calculator button. And I get quite a large number, 2058. And then some decimal places after, 549. There's a few more decimal places than that, but I sort of rounded it a little bit. And then, of course, I'll square root then to get the value of x on its own. I could leave it as x probably for the working, so I could change it to PQ now if I wanted, but I'll leave it as x. So x is 45.4, and the units in the question are meters. And I've rounded there to 1 decimal place. Just be careful with the units. Don't put centimeters for this question. You could potentially lose a mark. So just make sure that the units you include are the right ones. And that's the answer I've got. I'm having a quick look now. 45.4. That seems a reasonable answer because of this big angle of 122 means this side is going to be the longest side of the triangle. So that answer that I've got is quite sensible. Okay, so there's 2 questions there for you. What I'd like you to do is have a go at them. So now might be a good chance to sort of pause the video and have a bit of a go. And I'll come back on when you're ready, and I'll go through those 2 answers. Okay, so hopefully you've had a chance. I'll probably go through these a little bit quicker than the ones before, because I am very conscious of time, and we've already got 45 minutes for the session. So I'm finding side P. So it says in the question, find the length of the missing side marked with the letter, and the letter there is P. So I'm going to do the other 2 sides squared. So it's going to be 17 squared plus 11 squared, take away 2 times 17 times 11 times the cos of whatever angle is opposite P. And in this case, yeah, it's going to be 80 degrees. Okay, so quite a lot of information. A little mistake there in my part. Look, I put P there, but I haven't put P squared. So I have to be careful with that. So I missed the squared out. So I've just added that in. My pen is played up a little bit. So squared. Now I type all that in my calculator. I get quite a sort of long decimal answer of 345 point something, a lot of other stuff, which I'm not going to bother writing on the screen. But then, of course, I'm going to square root both sides. So the value of P in this question is 18.6 centimeters. And of course, I've rounded up to 1 dp. So I'm just going to put that in brackets. Okay, the next one, very similar question, but this time I'm finding W. So I'm going to do W squared. So I remember to do the squared that time. And it's going to be 6.2 squared. So it's the 2 other sides added together, of course, both squared. And that's going to be take away 2 times the sides. So 2 times 6.2 times 11.7 times the cos of the angle that's opposite the side we're finding. So in this case, the cos of 53. Only just managed to get that in. So the value of W squared would be 88 point some other stuff, which, you know, I'm going to leave on my calculator screen. I think it's worth mentioning now. I'm not going to round this off in any way. I'm not going to do the square root of 88. All of this number is still contained on my calculator screen. Okay, so you know, especially a calculation where it's got lots of steps, we always want to round at the end of the calculation. So we want to round halfway through or at different stages. I'm going to round at the end. So the value of W is going to be 9.4 meters. and again rounded to 1 decimal place. Okay, so that's pretty much finding the side of a triangle. What we're now going to sort of move on to is finding missing angles. So let's take a look. Okay, so there's the formula for finding the side, which we've just been through, and that's the only formula they give you in the GCSE exam paper on the formula page. They don't give you the formula for finding a missing angle. They only give you this one. So we need to do something with this. We sort of need to manipulate the formula a little bit, change it round, because really what we're after is this cos A bit to be on its own. That's what we're kind of after. And at the moment, of course, a squared is the subject of the formula, so we need to move stuff about. Now, because there's a minus and all of this in brackets, what I can actually do is add 2bc cos A to both sides. Okay, I'm not going to write that out, so hopefully you understand what's going on. So I'm going to add it both sides. So if you like, this comes over as a positive. So I'm going to write 2bc cos A. I'll put it in brackets for now. So I've added that on. This plus a squared is kind of still there, and it's all equal to b squared plus c squared. Okay, so that looks a bit tricky, I know, but actually what I've done is I've just added that onto both sides. So it's become a positive here. Think of this as all one positive term. And of course, it's gone from the right-hand side, but this a squared is kind of still there. So what I'm going to do next is I'm going to take away a squared from both sides. You're kind of going to minus a squared from both sides. And that leaves me with 2bc cos A. And if you notice, I've got rid of the brackets now because they're not really needed at this stage. Sorry, that's going to be b squared. So b squared plus c squared. And now it becomes a minus a squared because, of course, I've subtracted that from both sides. Now, we're nearly there. Now, I want cos A in its own. I've still got this 2bc in front. Because it's multiplied by cos A, it's multiplied by cos A, we can divide by 2bc both sides. So I'm going to write it as cos A equals b squared plus c squared minus a squared, all divided by 2bc. Now that seemed like a little bit of work, but it's definitely worth sort of remembering how to do that to move the formula around. So so we've got cos A on its own. Okay, so let's take a look. Now we mentioned earlier about using the calculator, and we mentioned about using the cos button when finding a missing side. When we're finding an angle, we will have to do the inverse of cos. So we have to press shift first, then press cos. And you have cos to the -1 come up in the calculator. If you look really carefully at the calculator, that sort of yellow cos to the -1, that appears under the cos, above the cos button. So that gives you a little bit of a clue. Okay, so let's take a look. Okay, so here's our first example of finding a missing angle. Now, I've been given 3 sides, and it tells me to find side x. So that's what we're going to do. So I'm going to start my formula off with the cos of x. Now, you've got to be careful here. There's a possibility of making a mistake here. What's A, what's B, what's C, if you think about the formula that I just introduced to you. Now, the 2 sides that are either side of x, they're the ones that are sort of positive, if you like. So it's going to be 19 squared plus 21 squared, and the side that's opposite x, which is that 23, that's going to be the minus 23 squared. Remember, all of those terms are squared, but like I mentioned, you can use the squared button on your calculator, and it's going to be 2 times b times c. So in this case, it's going to be 2 times those two sides, 19, and times 21. Now, of course, we're going to type all of that in our calculator, and we're going to have the cos of x equal to all of these values squared, added, and then subtracted, divided by this bit on the bottom. It may be worth keeping that in brackets on your calculator. 2 times 19 times 21. That might avoid mistakes, and that comes up as a decimal number, 0.2 3, 4, 2, I'll chop it off after 2. But remember, when we're finding a missing angle, whether we're doing right angle trigonometry or whether using the cosine rule, we always do the inverse. Okay, so if you like, we press the shift button and it becomes, I nearly wrote sine there, it becomes cos to the -1 of this value. Now, different calculators work in different ways. Some calculators, you can get that value and press cos to the -1. Some calculators, you have to store your answer. But that gives us 70.0. I rounded that on my calculator. It was 69.994. So that rounds pretty much to 70. And I've rounded to 1 decimal place. We don't really need the 0 there, but every other answer I've done is 1 decimal place. So I think I keep that the same. Okay, so the second example of that. Now the second example, they're kind of asking you in a slightly different way. They're asking you find the size of angle JKL. Don't be afraid to write in your exam paper, to write on questions. You know, you're allowed to mark the diagram as much as you like. So JKL is from point J up to point K to L. So I think I would definitely mark it on. That's the angle that you're finding. Okay, I could call it X if I wanted, but because it's called K in the question, I think it's sort of logical to keep it as cos of K. And that's going to be equal to these two sides which are next to it squared. So 19.3 squared. We're adding on 21.7 squared. We're taking away this opposite side, which is going to be 9 squared. And all divided by 2 times 19.3 and multiplied by 21.7. Okay, so again, I'm going to work that out and I'm going to keep this calculator answer actually on the screen. And it's, you know, 0.91017 and a few other numbers, but I'll leave that on the screen. But of course, to find that, I'm going to do the inverse of cos. So shift and cos. I'm not going to write it for this question, but hopefully you understand what's going on. So it's going to be cos to the -1, and that's give me an answer for K of 24.5 degrees, and that's rounded to 1 decimal place. Okay, so there's 2 examples of finding the angle. I think the important thing, if you're going to make a mistake anywhere for this question, potentially, it's going to be getting these numbers in the wrong order. So remember, the angle you're finding is the 2 sides that kind of create that angle. Okay, so it's the included angle in those 2 sides, and one you subtract is the one that's opposite the angle. So that's the way the top works. And then for the bottom is 2 multiplied by, again, those 2 included sides with the angle in between them. Okay, so 2 of those questions for you to have a go at. So have a try at them. Again, might be an idea to pause the video at this stage. Have a try have a try the questions, and I'll come back on and we'll run through the answers. Okay, so let's take a look. So they call them theta in this question. So that little symbol there looks like a little Easter egg. So they call it theta, and theta is often used to find a missing angle. So I'm going to write cos of theta. And I'll do this fairly quickly because hopefully you've done it at home when you're checking. So I'm going to do 17 squared plus 21 squared, when they're the 2 included sides. Take away the opposite side, which is going to be 8 squared, all divided by 2 times 17 times 21. That's going to give me an answer of cos theta answer of 0.93277. You're always going to get an answer of this less than 1 whole. But that, when I do the inverse of cos, remember shift and cos, that's going to give me an answer of 21.1 degrees, which of course, you know, I'm going to say next. I round that to 1 dp, so I can put that in brackets. The next one, cos theta again, because that's the angle we're finding. This side, the 2 sides are 2.6 and 1.9. So 2.6 squared plus 1.9 squared, take away 0.9 squared, and all of that is going to be divided by 2, multiplied by 2.6, multiplied by 1.9. Again, I'm going to get some decimal answer that just less than 1. In this case, it's 0.9676. I'll chop it off there. But when I do the inverse of cos, so remember shift and cos, and then type in that number, it's going to give me an angle of 14.6 degrees rounded to 1 dp. Okay, so we've done a few questions now on finding sides and finding angles. And they've been fairly straightforward, I think. They've just been sort of triangles on their own. But quite often in GCSE questions, there is a little bit more going on. So I think maybe that should be our next step, just to have a look at a few GCSE questions and sort of work those problems together. I will give you a bit of time to have a go on your own. So if you feel brave, by all means, you can pause the video, have a go at the questions yourself. But what I will say for the GCSE questions is you do sometimes need to think outside the box. So you need to think about your other rules that you've learned, such as angles in triangles, angles in parallel lines, angles on a straight line is a very common one. Remember, they add to 180 degrees. So there is often a little bit more going on with the GCSE questions. And an example of that is what we're looking at now. So I'll read through the question and then, you know, I'll give you a chance to pause and have a go on your own. So a flagpole AB of height 5.6 meters stands on top of a wall BC. So we can see the wall is indicated by the sort of thick line. The thick line there is the wall, and the flagpole starts at point B. Let's have a look. Yep. So ABC forms a straight line. So there's a straight line relationship between the wall and then the flag post continues to make that straight line. The wall leans slightly, so it makes an angle of 94 degrees with the horizontal ground CD. So whoever's built this wall is a bit dodgy, and obviously it's leaning over and it's not a very well made wall. The angle of elevation of the top of the wall from B at point D is 40 degrees. Now this is a bit naughty of them. They haven't given us that on the diagram. So all this other information is kind of given to us in the diagram, but for this they haven't. So it means the angle elevation. So if I was laying on the floor at point D and I was looking up to point B, it's this angle they're talking about there. That's the angle of elevation. Okay, so we have angles of elevation and we have angles of depression. This is the angle of elevation, which is 40 degrees. Now be careful, it is only that little angle there. It's not the entire angle. So that's given to us in the question. So it says, given that BD is 26.8, yeah, it gives us that in the question. Calculate AD. So where's AD? Let's have a quick look. So AD is this big line here from A sloping all the way down to D. So now might be a chance to pause the video, have a quick look, and then try the question yourself, and then I'll jump back in after you've unpaused and we'll run through the answer. Okay, so let's take a look at the question. I'm looking now, and I don't think we've got enough information as the question stands to answer it. So I'm looking, we're trying to find this AD. I'm going to call this X just for my workings. Trying to find that X there. I've only got one side in that triangle. I got that side as well, but I've got not much else. I've got no angles within this triangle, so that's not really good enough. So, but what I have got is two angles in this bottom triangle. Now we know angles in a triangle add to 180. So if I did 180, take away 94 and take away 40, gives me this angle here, which is 46 degrees. So this bit here has an angle. That corner of this lower triangle, or the bottom triangle, if you like, is 46. Now remember the key information earlier. It said earlier that it forms ABC forms a straight line. So this line is going straight up. So if that angle there is 46, the other side of that must be 180 take away 46. So this angle here is actually 134 degrees. So we now, I think, have enough information to solve the question because we've got an angle and the two sides either side of it, and we've got the side that's opposite the angle, which is the side that we're trying to find. So let's try and get some workings down. So we've got x squared, which is the side that we're finding. That's equal to 5.6 squared, which is one of the other sides, plus 26.8 squared, which is the other long side below it. And we're going to take away, in brackets, 2 times 5.6 times 26.8. You may notice my writing is getting smaller and smaller, so I'm going to fit it all on the screen. Multiplied by the cos of the angle that's opposite the side. Now, there's a lot of angles in this question. Make sure you choose the right one. That's 134. Just managed to sneak it on the edge of the screen. Okay, so let's type all that into our calculator. I'll leave that as x squared for now. So I'm going to square both these numbers, and I'm going to take away all of this in brackets. Okay, 2 multiplied by the sides, multiplied by the cos of 134. And I get a pretty big answer back, 958.109. We'll chop it off there. But of course, I want to square root that. So I'm going to square root that, both sides. Remember, in an equation, whatever we do both sides. So x is equal to 31.0 meters to 1 decimal place. It actually said 30.95 on my calculator screen because it's 30.95. When I round it up, it becomes 31.0. And of course, 1 decimal place. Okay, so that's our first GCSE question. Let's take a look at the second. So this one, again, is a bit more going on because there are 2 triangles in the question that are kind of stuck together. A little bit different to the last question where there was sort of one larger triangle with one inside. Let's have a look at what it's asking us. So a surveyor has recorded some measurements of a field on a sketch as shown in the diagram. Okay, it tells us the diagram is not drawn to scale, which you would expect with one of these questions. The surveyor needs to know the length of side AD to arrange for a drain to be installed. Calculate the length AD. So I'm just going to try and find where AD is. So AD is going to be from point A to point D. So there. So from that point there, from A to D, that's the side that we're trying to find. Okay, so I'll leave you with that for a few minutes. So by all means, pause the video at this stage, and then we'll come back in and we'll discuss the answer for the question. Okay, so hopefully you've had a chance to do that. And this again is one of these sneaky questions where we think we can find AD straight away. We've got enough information. We've got the opposite angle. That's okay. We've got this side of 224, but we haven't got anything for this side, which we can call that side AC, I guess, for now. But we've got nothing for that side. So we can't use the cosine rule because we haven't got enough information. So somehow we have to find this side. I think I'm just going to call it X for now, so it'll be easy for us to explain. This side X, we need to find that first before we find the side that we're actually after. And a bit of an indication with this question is it's a 7-mark question. So that 7 marks kind of indicates to us that we need to do a little bit more work. So maybe just one set of workings won't be enough for the 7 marks. Now, if you watched last week's session, we did the sine rule. I mentioned the sine rule is all about opposites. So we've got 49 degrees and a side that's opposite, 62 degrees and a side that's opposite. Now, we haven't got any information for that side, but that's the side that we're trying to find. So that's kind of one of the bits of information. I'm going to try and squeeze the workings over here, and I'll try and do the cosine workings the other side if I can fit it all in. So sine X. Sine X is what we're trying to find. Let's have a very quick look. My apologies, we're trying to find X. Okay, so we're trying to find X, not sine X. Now remember, if you're trying to find the angle, I would have started with sine X. Because it's a side we're trying to find, it's X. So a little mistake on my part. But remember, whatever we're trying to find is what goes on top. Now, the sine goes on the bottom because sine of 49 is the angle that is opposite the side that we're trying to find. Now, the other 2 bits of information are that's 142 meters. So 142 goes on top, and that is opposite the sine of 62, which is the other angle given in the question opposite that side. Right, I've got to squeeze that in a little bit. Now, I want to get x on its own. So this x here, I'm going to place there. And that sine of 49, I'm going to move it up to the top of the question. I got 142 multiplied by the sine of 49. I'm going to have to go over the picture a little bit here. And all of that is still divided by the sine of 62. Now, it looks a bit messy, but hopefully at this stage we'll find out what x is. So I can type all of this into my calculator. Remember, no use for the shift button on this question because I'm finding a side. Remember, I only press shift if I'm finding an angle. I type it all in, press equals, and I get an answer of 121.4 meters, and that's rounded to 1 dp, but I can write that later on. So after all that work, we know that that side x is 121.4, and now we can use that information to find this side from A to D, and this original side the question has asked us to find. So let's take a look. So AD, I think I'll leave it as AD. So there's quite messy workings here. There's a lot going on. So I think if I leave it as AD, hopefully, if you look back on this, you'll be able to see what's going on. And it's these two sides squared. Now, of course, these two sides are the one that I just found, which is 121.4. If you can, try and leave this value in your calculator, because I've rounded it to 0.4. But if you've got the value in your calculator as a stored answer, you're going to get a little bit more accurate answer at the end. And that's squared, and it's multiplied by 2 times 121.4 times 224 times the cos of the opposite angle, which in this question is 74 degrees, which is given to us in the question. Right, there's a lot of stuff going on there, isn't there? So we found the x first, and we've used that as this value in the formula, that 121.4, which hopefully is going to help us find side AD. So I'm going to type all of this into my calculator. So AD squared, and that's going to be equal to quite a large number. So it's 49,917, and again a load of decimal places, 0 to 0, 5. But of course, I want to find the square root of that. So I'm going to square root that side, square root that side, and that gives us a value of AD of 223.4 meters. Okay, so quite a lot of work with one question. I'm going to put 1 dp there in brackets, but hopefully you got that. But again, as I always say to my class, I've mentioned this before, if you've listened in, just do something. You know, you're not always going to get 7 marks for every question, but if you do some of that work, if you just do the sine rule bit, you're certainly going to pick up marks along the way. Okay, so I think we've got time for one last GCSE question. So I'm just going to go straight to GCSE question 4, which is this one here. And I picked this one because this does look at a few other skills as well. So let's have a look. So I'll read through the question. Again, I'll give you a little bit of time. So a cruise ship sets out for Port P. From Port P. So it starts at Port P there at the bottom of the screen. It sails 95 kilometers on a bearing of 58 degrees. Okay. And then it gets to Port A. On the following day, it sails 147 kilometers on a bearing of 310. So remember, bearings always from north clockwise. So that large bearing of 310 degrees to its second port of call, B, which is there. The day after that, it sails back to Port P by the shortest route. So let's have a look at what the question's asking. Calculate how far the cruise ship sails to travel from B to P. Now, I'd use a rule of this normally, but it's going to be difficult on the screen. So I'm going to try and sort of, oh, this is looking a bit dodgy, this line, to be honest. If I used the rule, it would be a lot neater. But imagine that's a straight line. It does look like the ship's going through wavy waters there a little bit, but imagine that as a straight line from B to P. That's kind of what you need to find. Okay, so now would be a good chance to pause the video and I'll come back in and I'll go through the answers in a moment. Okay, so hopefully you had a chance to do that. We haven't got a lot of information in this question. Okay, we're trying to find that side. We've been given that side and that side, but we haven't got a lot in the way of angles. I mean, this 58 isn't really going to help us immediately. So let's have a look what we need. Now, if you notice, both bearings, both north pointers are facing north, of course. So these are parallel lines. So I'm looking at this big angle here, this big angle here, that angle of 58 and that big angle I've just drawn in red, they're going to add to 180. So if you do 180 take away 58, this big angle here is 122, that large angle there. But this smaller angle, which I'm marking there, smaller angle, which is in there, has to be 50 degrees. So that angle there, I'll just put a little line outside, that has to be 50 because if the full turn is 360 and the bearing is 310, 310 take away, 360 take away 310 gives us this bit, which is 50. So the angle we actually want is this one I'm pointing at here. Remember, there's nothing wrong with drawing these little things on your paper. It's going to be 122 take away 50, which gives us this angle here of 72. Now it becomes a fairly straightforward question because I've got the angle opposite the side that I'm finding, which I'm going to call X for the purpose of this. I've got this side of 147 and that side of 95. So my workings now should be fairly straightforward and very similar to the workings I've done already this lesson. So 142 squared plus 95 squared. I'm going to take away 2 times 147. You could probably guess we're going to get some pretty big numbers from this. Times 95 times the cos of this very important angle that we just found, which is 72. I'm going to type all that into the calculator and I'm going to get a pretty big number of 22,003 and some decimal places after it. I'm going to do the square root of both sides and that gives us an answer of 148.3 kilometers, because the question's in kilometers, to 1 decimal place. Does that make sense? I guess with the numbers I'm given in the question, 148 kilometers sounds perfectly reasonable. Okay, so a little bit of a rush there at the end just to get to that question, but I think the important thing to take away from that is you have to work out this angle that's opposite the side that you're finding. And if you look closely at the question, look at the parallel lines, looking at this angles around the point, I think you'll certainly get there. But like I mentioned at the start, we need to revise those skills as well. Okay, so let's take a look at what we've covered so far. So we've done a bit on the formula and the sort of notes on the formula page. We've looked at the cosine function on the calculator, and of course we use that for the side and for the angle. We found a missing length and then a missing angle, and we did cover some GCSE questions. Okay, just to leave you on a quick plenary, and I think we could get this done, in about a minute. It's quite a short plenary, so we're not actually working anything out. But all we're doing is we're looking at the question and identifying, is it a sine rule question or is it a cosine rule question? I've marked each of the sides or angles with an X. So take a quick look. So if we're finding angle X or if we're finding side X, would you use the sine rule or the cosine rule? So take a look at that and I'll come back in and I'll run through the answers in a moment. Okay, so let's take a quick look. So the first question here, I got it's all of opposites. No, it's not, sorry. This first question, I've got the angle and the two sides either side of it. So that's definitely the cosine rule. Okay, so remember I've got the included angle between the two sides. The next one, I've been given 3 sides to the shape. So the 3 sides, but no other information. So that's got to be the cosine rule to find the missing angle. Question 3 is about opposites. So I've got 19 opposite 61 degrees. And I've got 67 opposite the side X. That's going to be the sine rule. I think the same for number 4. 39 degrees is opposite 11 and 9 is opposite the side of the angle I'm finding. So that's the sine rule. And then the next one, I've got the two sides and the included angle again. So that's the good old cosine rule that we've looked at this lesson. So just make sure that you're familiar with the distinction between when you would use the sine rule and when you would use the cosine rule. Okay, so that's pretty much the end of the session. Please stay for the next couple of sessions, which are going to be run over the next couple of weeks. Thank you for joining us. Back to you, Mrs. Dixon.
Thank you, Mr. Casey. I hope you all found today's session useful. Session 3, next week's session, will focus on probability tree diagrams. We hope to see you then. Bye.